I've got one part of the fundamental theorem of calculus in the top right part of our board. It's saying that if you have a capital function f of x and it's integrating a lowercase f function with respect to some other variable, then its derivative is going to be this inside function in terms of x. Basically, if you take a derivative of an integral, then with some conditions, the result is going to be this function here with the upper limit of your integration plugged in, right? So kind of complicated. Basically, a derivative of an integral, they kind of cancel out, but there's some details there, right? So what's happening is we're evaluating the integral from 0 to cosine of x. We have to watch out for the chain rule. Whenever you whenever you evaluate a derivative of an expression, the chain rule has to happen. The derivative of this outermost function is just the square root of 1 minus cosine squared x. And we can do that because of the fundamental theorem of calculus. Our x is like cosine of x in this expression, okay? So the derivative of this outermost function is this. But the derivative of the innermost function of cosine of x is sine of x. Negative sine of x. Whoops, sorry. That's negative sine of x because of the chain rule. The derivative of cosine is negative sine. Put a parentheses around that. Okay, so that's the big kicker to this question. You've got to make sure you apply the chain rule. And so now we can simplify a little bit with the Pythagorean identity. This is sine squared x times negative sine of x. And so the square root of a square number is just itself, but we have to have an absolute value here because sine can go between -1 and +1. It's getting turned into a positive number when you square it, though. So we're only getting positive values out of sine of x. So for the practice computer's having trouble. Practice midterm, that's why this is the correct answer. I'm not sure what it looks like with multiple choice, though. Sine x times negative absolute value sine of x. So it looks like the negative sign has just been rearranged there, but that should be the correct answer.